So what we are going to be talking about in this lesson is the laws of logarithms. So just like how we had laws of exponentials and stuff like that, it's kind of the same rules when you see when we were talking about that little song and dance that we used to talk about. So if we were to just take a look at this really quickly, it says let b be the base of your log function. Make sure it's not 1 and it's greater than 0. And let m and n be positive numbers, right? So if we take a look at number 1, it is saying, hey, when you're multiplying your two values here, your two variables, when you want to expand them or make them, expand them basically, we're going to be adding. So remember that song, when you multiply, you add? Well, guess what? When you divide, you're going to subtract. So that song did not go away. So when you multiply, you add. When you divide, you subtract. Same thing happens in logs. The only one that is a little bit different is your power one. When you have a power, so we have m to the k, what we're going to end up doing is we're going to end up moving that k to the front of our equation. So this little k becomes a big K in front of the log. Not that big of a difference. This is very doable, and we can totally see what this is happening. So in case you're a little lost, let's go ahead and do an example or two. So let's see. Here we have log base 2, 5 times a times b. So we just said when we multiply here, all our variables are being multiplied, we are going to end up adding them. So we're going to just go ahead and expand all of them and make sure that they all have the same base. So log 2, base 2, of 5 plus log 2 of a plus log base 2 b. And that's it. That's all you have to do to expand it. You just add plus signs whenever you are multiplying. Let's take a look at dividing. So when you divide, you're going to subtract, and make sure your numerator is always going to be the first number. So in this case, log base 5, my numerator is going to be the first number. My numerator is the top one, 8, minus log 5 to the x. Pretty simple. So we're actually going to be using this when we're solving for logarithms and exponentials. So this will come in handy when that happens. But let's go ahead and do some other ones with a little more complications to it. So this one's going to be dealing with k's. So with k's, what I want you to do is wait until the very, very, very end to mess with them. Don't go ahead and put your k's right now, because that's kind of the rule of, like PEMDAS and stuff like that, there's an order of operations. So what we want to do is make sure that this 2 only belongs to this x. So if we were to do it right now, I wouldn't know if it goes to the 2, to the 6, to the x, or the y. So we go ahead and save that for the very end. So right now, we can see that they're being multiplied. So I could separate that first. So I go ahead and separate that. I'm going to be adding. Right? Then I know, hey, I have these exponents, and I want to move them in front of that log. So the way it's going to look is it's going to be 2 log 2x plus 3 log base 2 of y. That's it. So I'm going to go ahead and rewrite over here the first one. And that's it. This is my answer, the second one. This is it completely expanded. So I don't want to leave it up like this one because I have these exponents up here that I want to make sure that they're converted into the proper k. Okay. Let's go ahead and do this last one here. We'll get to more complicated ones later. So what we want to do first is the dividing. We want to separate the two divisions. I know it sounds backwards because of PEMDAS and whatnot, but let's go ahead and do that. So here we have log base 3 4ac minus log base 3 bc squared. Oh, I said c instead of squared. Whoops. All right, so we have this separated now. Okay, we're good. But we notice, hey, they're being multiplied. So what we are going to do now is separate these two. So we have log 3, 4 plus log base 3 a squared. But I continue off with over here, hey, these two are being multiplied as well, so I'm going to add them. That's 3. So it stopped recording, I don't know. But all I went ahead and did is moved my k's to the front. As you see, my 2's got to the front, and that's pretty much it. So if you went ahead and did that, that's great. Okay. Let's go ahead and flip it. As you see the little note that says up here, when no base is written, that means we're going to have a base 10. This is our basic log, so common log, that's what it's called. So let's go ahead and go backwards. So we're going to be actually condensing now. So now that we have here, when we are adding, what are we doing? We are multiplying, right? But we see something right here. There's a big 3. What we're going to have to do, this is our k, we're going to have to move it in front with our x. So it's going to look a little like log 5, 7 plus log 5x to the 3rd power. And then we tell ourselves, hey, they're being added, so I am multiplying 7 times x to the 3rd. Now, keynote. Make sure they're both the same log base. So here, they're both base 5, so I can do that. Make sure you do that, because if not, you can't condense or expand anything like that in that nature. So just make sure you're doing that. Let's take a look at this one, number 7. Hey, these two are being subtracted. So that means they are being divided. And I know we can do that because they're both base 2. Now, remember, my numerator is going to be the first one. Bingo, that's it. Number 8. You can see, hey, there's a number in front. That's my k. What do I need to do? I need to put it in front of the m. Same thing with the 3. I need to put it in front of the n. So I have log 6m to the half power minus log 6n to the 3rd power. And I say, hey, that is subtraction. These are both 6. I know what I can do to simplify. I am going to be dividing half over n to the 3rd. Now, if you know that half is square root, even better, you can go ahead and write log 6 square root of m divided by n cubed. That is even better. But you do not have to. If you do not think that is necessary, that is fine. Last 2. This one's a little bit different because my log is right here at the very beginning. Now, this is my personal preference of how I like to do it, but I'm going to wait for this one till the end because I know for a fact, hey, it belongs to both of them. So I'm going to go ahead and save that for the end. I'm dividing because I am subtracting. They're both base 2. I can do this, right? This is log 2a divided by b, right? But that 3 was still hanging out in front, right? What I could do now, put this in the exponents for both of them. So it's going to be log base 2a divided by b all cubed. Last one. If you want to go ahead and pause it and try it on your own, I encourage you to do so. But if not, let's follow along. Here we are being tested with the idea, hey, multiplying and subtraction. Which one am I going to do first? Well, first we're actually going to do our k's, right? So let's go ahead and do that. Put my k, right? Minus log base 3n squared, right? Now I'm going to do this from left to right. Left to right. So these two I am multiplying. So I'm going to go ahead and do those two first. M cubed and I could do that because they were both 3's, right? Base 3's. Last step, hey, these two are dividing because they're both base 3 and they are subtracting. So log base 3, 4 times n cubed divided by n squared. And this would be our answer. And that's it. This is not that complicated. So the laws are basically condensing and expanding logs. So we could go from this side to this side or this side to this side. We are expanding when it gets bigger. We are condensing when it gets smaller.